What is a sine wave? First of all, imagine you're tracing the circumference of a circle. On another graph, you keep the y value the same, but the x value is equal to the angle subtended by the arc you have created. We can now generalize all sine waves using the form amplitude with time is equal to peak amplitude times sine omega t plus or minus theta. A is the amplitude of the wave, equal to the radius of the unit circle. Omega is the angular velocity, the speed at which the angle changes within the circle. Angular velocity is defined as 2 pi times frequency, the number of oscillations per second. Theta is the phase and changes where the wave sits on the line. There are two ways to describe a point in 2D space. One is polar and the other rectangular. You are probably already familiar with rectangular form. It takes the form x, y and describes a point based on how far up the x and y axis it is. The other form, polar form, takes the form radius angle theta. Using our unit circle from earlier, we are able to plot any point by simply adjusting the radius of the circle and the angle. To convert from rectangular to polar form, we need to first acknowledge a few mathematical concepts. To plot a circle on an xy Cartesian plane, we use the formula x squared plus y squared equals radius squared. Rearranging this gives us radius is equal to the square root of x squared plus y squared. We are halfway there. In trigonometry, tan of an angle is equal to the side opposite to the angle divided by the side adjacent to the angle. Since in our unit circle our opposite side is equal to y and our adjacent side is equal to x, when we rearrange we find that theta is equal to the inverse tan of y on x. That's all well and good when converting from rectangular to polar, but what do you do when converting from polar to rectangular? Trigonometry tells us that cosine of the angle is equal to adjacent over hypotenuse, and sine of the angle is equal to the opposite side of the hypotenuse. We know from earlier that the adjacent side is equal to x and the opposite side is equal to y, thus cosine theta is equal to x over hypotenuse, and sine of theta is equal to y over the hypotenuse. Rearranging and replacing the hypotenuse with the radius, we find that x is equal to r cosine theta and y is equal to r sine theta. Thank you for watching this video. I hope you learned a thing or two.